All right. So our second speaker of the day is Benny Powers. He is a principal user experience engineer at Red Hat. And he's been working with open source software for quite a long time now. He joined Red Hat in 2022, and he now works on designing systems and web components in the experience engineering organization. So over to you, Benny.
Thank you, Mohit. Okay, so thank you to Otavio for the previous presentation on AI. Very interesting. So we're going to move from something that's very cutting edge and has a lot of questions around it. We're going to move now into something that's much more traditional and more familiar to a lot of the developers on the call. Specifically, we want to talk about testing UI components in a web development context. Okay. So the approach that we've developed, I work on design systems for Red Hat. And the approach that we've developed, one of the approaches we've developed, we call it semantic component testing. And we can think about this as an alternative to visual regression tests, but one that puts usability and accessibility front and center. So let's just review what some of the traditional UI component testing approaches are. Okay, so you might use DOM property testing or framework property testing. And I'll get into each of these in a little bit more detail in the slides to come. You might do a DOM snapshot, which checks that you get the correct HTML back for the state of your components. And of course, there's visual regression, which is comparing screenshots of your components, before and after. So what's DOM property testing? So the idea there is you might have a UI component like this card, and you might change some state about it or have its state changed, and then you want to make assertions about what happens to the properties of that card. So for example, if I call the open method on my components class, then I expect the component's expanded property to be true afterwards, right? Just a little side note, I'm going to be using examples in the code here, which relate to web components and DOM components, but the techniques and the ideas are just as applicable to like VDOM components or other frameworks. Just sort of, if you need to mentally translate from DOM properties to state store paths or something, so do that translation. Okay, yeah. So DOM properties, we're basically asserting on the public APIs of my component and making sure that everything works the way it's supposed to. Okay. The advantage of this kind of testing is that the assertions are very easy to write. I call the method, card.open or whatever, and then, I assert that card.expanded is true. Easy peasy. And it also corresponds directly to the public state and methods that are available on your components, right? So this kind of testing, this kind of unit testing remains very helpful. But there are some drawbacks. For one, you gain a low degree of confidence from this kind of test that your components are actually going to work for the end users, because who said that just because the expanded property is set to true, that the user can actually see the content on the screen that they're supposed to? As well, you have to write these tests in a very serial way. You have to test each call and then each property afterwards. And these kinds of tests don't give you any insight into the resulting DOM in your component. They don't tell you anything about the accessibility tree, and they don't tell you about the styles of your components. So that brings us to another kind of testing, which is DOM snapshots. Right? So you might perform some action on your component and then want to assert that the resulting HTML that you get on the page matches some previously cached snapshot of what it's supposed to look like. So like when I call the open method on my card, then the shadow roots HTML should match the last known good snapshot exactly one-to-one, byte for byte. So the advantages to this kind of testing are the high degree of confidence that you get. You can make your changes to your private methods or whatever, and then see that, okay, everything's working exactly the way it did previously. As well, you don't have to write assertions on every single property, because with one snapshot comparison, you validated the entire DOM. And so in that sense, the assertions are much easier to write. It's like, call my method, assert that it matches the snapshot. Great. Okay. But like the DOM property testing, there are some drawbacks to this method as well. For example, the snapshots that you have to keep around in order to compare against are tightly coupled to the DOM structure of your components. And you might have reasons to want to change that DOM structure, and that DOM structure might be private to your component. It might not be something that is intended to be exposed to end users or to downstream developers. So every time you change that DOM, you have to update your snapshots. And you have to do that every single time manually, every time you want to either make a change to your components or make a change to your tests. As well, you can only validate the serializable state of your components. What do I mean by that? So for example, let's say you used the ARIA IDL interfaces, ARIA IDL properties on an element internals object. The element internals object is sort of an in-memory private area where developers of components can set ARIA properties and different sort of default semantics for an element. And those properties won't necessarily be reflected to the DOM. So what that means is if I set this ARIA label property on the element's internals object, it might not actually make a difference to the DOM structure, right? And if I'm relying on my DOM snapshot to expose changes to the state of the element, I won't get that in my snapshot. This could be even more tricky to work around in terms of testing when you have elements in different roots of the document. So I might have an element in my shadow root for my component, and I might assign another element in the document, in the light DOM, as one of that element's ARIA associated DOM nodes. When you do that, you don't get an ARIA active descendant ID reference on the referenced element. You don't get a string ID reference. It's all held in memory by the browser. So this might be correct, and it might work in certain cases with assistive technology, but you wouldn't be able to assert that it's true just by looking at the HTML. Okay. So another kind of testing that's in our toolkit as testers is visual regression. So that's when you take screenshots of your elements and compare the before and after, and use some software to compare pixel per pixel. And if it matches, you pass, and if it doesn't match, you fail. This particular comparison will fail, and I wonder if you can tell what the difference is between the two screenshots, because they are different. Okay. So the idea here is when I call the open method on my element, after all the browser's animations have stopped, then the element should match the last screenshot that I took of that state within, let's say, a 1% margin of error. That's the idea of visual regression testing. So like the other varieties, there are a lot of advantages to VisReg. So you get an extremely high degree of confidence with this kind of testing because, I mean, if it matches, it matches. We're good. We didn't break anything, right? As well, with visual regression, oftentimes the tools that are used to produce these to run these tests and produce reports can, upload a comment to your GitHub thread with a comparison between the before and after, and that can be very helpful for reviewers. But like the others, there are some downsides here. So you don't get any insights into the state of the DOM, of the HTML, and certainly not into the accessibility tree. It's just pass or fail. Do the pictures match or do they not match? As well, running these tests cross-platform can introduce flakiness and weird effects. The font rendering on macOS is different in Chrome is different from the font rendering on Linux and Firefox, which is different from the font rendering in Windows in Chrome. So those differences can be annoying, let's say, to work around. Now, there are workarounds for that, like containerization and whatnot, but it's something to be aware of. And you also have the same maintenance issues here as with the DOM snapshots, because you have to constantly be updating your last known good screenshot every time you update your components, and that can be annoying. There's another kind of testing which is useful in our field, and that's accessibility audits. So here's a screenshot from Chrome's Lighthouse, and maybe you've run these tests on your websites before. These are great when you want to get detailed information about the entire page. Are there any identifiable accessibility problems there? Right? And when you run these kinds of accessibility audits, you're basically saying, does the page pass the audit? If it doesn't, which audits does it fail? Okay. So the advantages of accessibility audits is that they work great for whole pages or entire applications, and they provide these comprehensive reports, which can be very useful to teams in order to ameliorate accessibility issues. But the downsides here are that they can be quite costly to run. And if you're doing a bunch of unit tests on your component, it might introduce significant performance issues to run a full page accessibility audit every time you change some of the state. You know, a test file that has 100 assertions in it, and you're going to run accessibility on each one of them. It can be a lot. As well, the tools that you're using to do the audit, the most popular one is Axe from the Q University. It may not have access to that in-memory state, accessibility state that we talked about previously. It might also just be running assertions on the DOM, and that depends on the tool that you're using, the upstream tool that you're using. So there's a potential for false positives in that case, where the tool might say that something's inaccessible, whereas users of assistive technology might not actually have any problems with that. Okay, so that brings us to something that we've spoken about a little bit earlier, which is the browser's accessibility tree. I mentioned this in passing previously, and now I just want to explain a little bit what I mean when I say accessibility tree. So, you know, the browser for each page, just like it creates a document object model, which is a tree of JavaScript objects that represent all the HTML in the page, it also creates this accessibility object model, this tree of accessibility nodes, and it passes that tree to assistive technologies like screen readers. So users of those assistive technologies, they're really, in a way, they're really interacting with the accessibility tree more than they're interacting with the DOM tree or with the HTML page the way that non-assistive technology users might do. So here's a screenshot of Firefox's developer tools for the accessibility tree. So you can inspect all the nodes in the accessibility tree, their states, their relationships between different nodes. And that's a very useful tool. I highly recommend that testers get acquainted with it. The Chrome browser also has an accessibility tree inspector, which operates very similarly to Firefox's, provides a little bit more information in some cases. As far as I know, WebKit Safari doesn't provide an accessibility tree inspector. I'd be happy to be proven wrong if you're aware that they do. But if you look at the bottom right of that screenshot, you can see, you know, in the DOM node inspector, there's a little accessibility section where at least you can inspect some of the accessibility properties on a given DOM node. So that could be useful. And all of that tree information is passed to the browser, not exactly in this JSON format, but in something like this kind of JSON format, where you could see that we have these different nodes in the tree, and they have roles and states and relationships, et cetera, et cetera. And that brings us to the topic of our talk, which is the idea of semantic component testing. The basic idea is that instead of asserting on the DOM or asserting on the visual state of the browser's renderer, we're actually going to make assertions against that accessibility tree. When I call the open method on my element, does assistive technology have access to that list box, right? So it's like when I click the combo box toggle, assistive technology should have access to the list box. That's the testing mindset that we're going when we do this kind of semantic component testing. So here's an example of one way that you might do this, right? So this is from like a Mocha Chai test, you know, old school. If it ain't broke, don't fix it, they say, right? So you might run a click function that goes and puts a click on your toggle button, and then afterwards we'll make our assertion. So we can get that snapshot with that await statement, await expression, and then what you might do is you might do a comparison of the snapshot to make sure that it equals your expected snapshot, right? So this is sort of similar to the DOM snapshots approach that we took earlier. On the one hand, it's great because it's very comprehensive. On the other hand, you have the same kind of maintenance issues that we talked about before, as you have to constantly be updating this expected accessibility tree copy, right? So what we've developed on our team at Red Hat and the design systems team is some chai helpers. So instead of making assertions that, you know, my output matches the expected accessibility tree, we have some chai helpers. So you can get your accessibility snapshot from the test runner and then assert that the tree contains a role list box, right? So if the list box is available to assistive technology, it will be in the tree. And if it's not available to assistive technology, it won't be in the tree, right? So if the element is hidden or ARIA hidden or something like that, it gets removed from the tree altogether. So I have some chai helpers which say, you know, I expect my accessibility tree to contain a list box after I open up the toggle or whatever it is. And we have some other kinds of chai helpers like this one down here. which checks to make sure that the focused node in the DOM tree, the one that has keyboard focus right now, it has to have a certain label, or it has to have a certain role, or it has to, meet some other criteria that I've determined in my tests. The main advantages here of this kind of semantic component testing is that it really puts usability and accessibility for end users front and center. It's mainly concerned with what assistive technology has access to. And this gives us something that's called the curb cut effect. So if you've never heard of the curb cut effect before, a curb cut is, when you're walking down the street and you come to the curb and you're about to go down into the roadway, and there's that little dip where, a wheelchair user could roll comfortably out onto the sidewalk without having to, bump down from the curb. Now, when these were first invented in America in, I think, the 1970s, what they quickly discovered was that although they had intended for these curb cuts to be used primarily by wheelchair users, they had benefits for all kinds of people: bicycle riders, parents with trolleys, baby carriages, shoppers that were, carrying lots of goods in a wheelbarrow or something, right? So the curb cut effect is the idea that by making your product and your processes more accessible to users with disabilities, you'll also be benefiting users that don't have those disabilities in ways that you might not be able to expect. Now, another advantage here, so to make the curb cut effect more explicit here, is that this kind of testing is asserting on the effects of your changes to the accessibility tree rather than asserting on the state of your private component DOM structure, right? So by doing that, you're asserting that we really do have a correct state after we've made our changes. But like the other varieties of testing, there are some downsides here as well that it's worth discussing. So in our tests, we use the Playwright test runner, which runs our tests in a headless browser. And Playwright is the component that produces that accessibility tree, that big JSON blob that we can assert against. And that accessibility tree might not actually contain every feature that the browser is aware of that it delivers to assistive technology. And I alluded to this earlier where I said that that big JSON is not a one-to-one mapping with the accessibility tree. So that's something to keep in mind. It depends on the tool that you're using in order to gain access to the accessibility tree. I also expect this to get better and better as standardization around this kind of testing improves among browser vendors. Another downside to this kind of testing is that actually the API that Playwright provides to gain access to that accessibility tree JSON is scheduled to be deprecated. Now, as of this talk, the Playwright team has heard from the community that there are some use cases that they might be interested in. So they're not going to get rid of this API just yet. But I think if this kind of testing sounds interesting to you and sounds like it could be useful for your team, I would encourage you to let the Playwright team know that this is interesting, as opposed to something like the accessibility audits, which run on the entire page. So I prepared this table, this chart of sort of the pros and cons of all these different varieties of testing. So for DOM property testing, we don't really get any of that usability information out of our tests, and we don't get these kind of comprehensive reports that you might get from other methods. But it is very well adapted to component testing, and it's quite performant because I'm just accessing my asserted property and checking it and moving on to the next test. For DOM snapshots, we also don't get any of that. Well, we don't necessarily get the usability. You might be able to assert on ARIA attributes, but those might not accurately reflect the actual state of the accessibility tree. We could get decent reports out of it, diffs between what should be and what is. It's quite well suited to components, but it's not particularly performant. For visual regression, we similarly don't get much of that usability information, but we get great reports. It can be quite useful for components as well as for whole pages, but it's not the most performant thing in the world. There's a lot of image processing. You have to store a lot of data. You have to store your image snapshots somewhere. Accessibility audits on the full page are all about usability, so they're highly recommended in that regard. And they do produce those very detailed, actionable reports, but they're not the most well-suited thing in the world for component testing, and they can introduce some slowness in your testing process, depending on your setup. And so semantic testing, the kind of testing that I'm advocating for today, gives you that usability information. It doesn't give you necessarily a comprehensive report. You kind of have to roll your own reports after the fact, but it's particularly well suited for components, and the tests themselves can be quite performant indeed. So I want to thank you for coming to this talk and learning a little bit about our testing approach. The tools that we are using to do this come from two projects that I'm involved with. One is Modern Web, who produces a tool called Web Test Runner that uses either Playwright or Puppeteer under the hood to run your tests. It's kind of like a modern version of Karma. And that's how we gain access to the accessibility tree. As well, the Chai Mocha helpers that we've produced in order to help us query that accessibility tree after we've generated it in our tests. Those are available in the Patternfly Elements project. So if you'd like to do this kind of testing on your web components or even on your framework components, we'd be very happy for you to use some of our tools and let us know what you think. That's it. I'm happy to take questions.
Right, very informative talk, Benny. I really learned a lot from this, things that I did not know about before. Anyone in the audience, if you have questions, please feel free to raise your hand and go ahead.
So Benny, I have one question regarding, so you mentioned about the Playwright duplicating the API access to the DOM basically.
Mhm.
And at the same time, they were having the accessibility integration with any other tool, like, or they are planning to add something like that on top of the existing one.
Okay, yeah, so the specific integration that we're interested in here is not, instead of being to the DOM tree, it's to the accessibility tree, right? So in the Playwright test, you have full access to the DOM because they run in the browser. So in our unit tests, we do all kinds of DOM querying and checking on elements and DOM nodes and stuff like that. But specifically in these tests, what we want to get is this accessibility tree representation, which is different from the DOM tree. It's the assistive technology tree. So that comes to us something like this, right? Where these children here, they're not DOM nodes, they're accessibility nodes. Now that comes from a Playwright API, which queries the browser's accessibility tree and produces this JSON object for us to query against. Now that feature of Playwright where you get this JSON representation of the accessibility tree, that might be deprecated in the future. I hope it won't be because it's quite useful for us. But the Playwright team has produced another kind of accessibility test, which basically just runs the AXE audits on the page whenever you call it. It just sort of like runs the whole page audit whenever you do your stuff. And that's useful, but it runs across some of the problems that we spoke about before, like the performance issues and that they're not focused on particular components. Really, in my view, it's sort of the difference between kind of end-to-end or integration tests and unit tests. It's sort of a different take on testing. I hope that answers your question.
Yep. Makes sense, Benny. So I have, in terms of accessibility, right? So what your take on, like, is it good idea to build the components accessible so that your ultimate website that are using the component will be accessible?
Yeah,
or is it, or is it like build a website and then go to the user and come up with the feedback and then make it. So
right.
what do you think? What is the better way to do?
Yeah, that's a great question. I think the sort of general advice is that as much native HTML you can use, that's the way to go. Instead of using fancy custom components and things like that, really the native HTML is the way to go. Now, if you're going to make your own custom components, which seems to be the fashion these days, so then you have to really be aware of the established accessibility patterns. I recently shipped a type ahead combo box, that you type into the input and the options show up and you can navigate through the options while you're typing. There's so much accessibility information that you need to be aware of. The focus has to stay on the input, but while you're on the input, you have to be able to move through the menu. So there's a visual focus, and then there's an assistive technology focus, and there's a keyboard focus, and those are all three different things that you have to coordinate. and you have to set up relationships between the input element and the list of items and which item is focused, and there's a button. So you have to be aware of all these things, and it's quite comprehensive. So if the lower level components are not written with accessibility in mind, it can produce knock-on effects that multiply against each other when it comes to developing applications and experiences with those components. That being said, just because the components have been written to be accessible and tested and confirmed with manual screen reader testing, et cetera, that doesn't guarantee that just putting that component on your page makes your page accessible, or even the way you're using that component is accessible, right? So like a select menu might require you to add a label to it. If you don't add that label to the select menu, it's not going to be accessible, no matter how good a job the component authors did. So accessibility is really something that needs to be included at every level of the development process. We've even received designs, like mock-ups and Figma designs and things like that, which contained within them accessibility problems which couldn't be fixed by the developers. No amount of ARIA attributes could fix those things. We had to send those designs back and say, well, consider the tab order. How is a screen reader user supposed to have this experience? So I would encourage you and your teams to make accessibility and accessibility thinking part of the development cycle, from the gathering requirement stage all the way down to the end-to-end testing at the end.
Thanks, Benny. I think you had covered a lot of ground, starting from the design to the actual testing, end-to-end testing. Thank you. Thanks for that information.
Please.
Penny, just wanted to check if there is any repository that we can use as a reference. I guess you mentioned the Patternfly elements link there, but any.
Yes.
Okay, so we can we could find examples there which we can reference.
Yes, that's right. A lot of our test files use this approach, and they use some of them use the tools that we've released. A lot of them make assertions against the accessibility tree, so you can check there.
Okay.
Yeah, I would encourage you to do that.
Okay, thank you.
Okay, great. Thank you very much. So I'm going to hand back to Mohit, and I think we're going to go to break now, right? Thank you.
Yeah. Thanks, Benny. Good talk. So we would now take a small 10-minute break. Go grab your coffee, stretch your legs. We have 2 more interesting talks after this from Faisal and Meenal, and we would be starting with them in exactly 10 minutes from now. Thank you, everyone.